Hi, now in this video I'm going to discuss a few more concepts regarding wave equations, diffraction and the connection between diffraction and wavelength. So here are my concepts. First of all, we know that in the mechanical wave there are two basic types, the transverse wave and the longitudinal wave, right? The transverse wave is the one in which if the wave is traveling towards the right hand side direction, the molecules will move up and down. That is the direction between the motion of wave and the direction of the particle through which the medium through which this wave is moving. Its particles are moving perpendicular to the direction of motion of wave. So this is the direction of motion of wave, and this is the direction that is up and down is the direction of motion of the particles. Okay? This special type of wave is called transverse wave. It has its point which are up and down. So the topmost points are called crests and the bottom points are called troughs. Right. One very important thing which everybody must know is the wavelength. What do you mean by the wavelength? So the wavelength is, if I consider the starting point of my wave is this, the wavelength must be the distance which is continued through the wave until unless we come across with another point which is about to perform the same motion. So for example, this point is actually moving down, right? If this point is actually moving down, so which next point is moving down in the same way? You will go along this wave and you will find that this is the point which is also doing the same function. Similarly, you go to this point and it's also doing the same function. So the distance between these 2 points will be called the one wavelength. So if you are not starting from here, balki you are starting from the topmost point like this, so if you go the distance from here to here, then this distance will also be one wavelength. It is represented with the letter lambda and its unit is meter or centimeter, right? So it's just the length. Similarly, if I go to the other type of wave which is called longitudinal wave. So the longitudinal wave has a specific description in which if the wave is traveling this way, this is the, for example, this is the motion, this is the direction of motion of wave. If I just consider this particle over here, so this particle is moving back and forth and back, forth and back, that is towards right and towards left, towards right, towards left, and also the wave is moving in the same direction. So this is a special type of wave in which the particles of the medium are moving along the direction of motion of wave. Okay, I'm writing just to make you understand this. You can revise, you can go back and listen to whatever I'm saying, right? It contains the point where the wave medium, the medium through which the wave is passing, the particle of the medium comes closer together, that is this part, and where they move a little bit far apart. So the point where they are closer together are called compression, and the point where they are far apart are called rarefaction, right? Okay, so let us quickly go down to the next concept which is required for the question. It is related to the sound. As you know that a sound is a form of energy and it travels in the form of longitudinal wave, right? So there are a few facts from your syllabus. I'm actually relating it over here so that you can see it and remember it. Our human ears have a special range of frequencies which we can recognize, that is 20 Hz to 20,000 Hz. Remember that this is the frequency I'm speaking about, not anything else. Secondly, medium is needed for the sound wave to travel. As it's mechanical wave, it requires medium. Otherwise, in the space, if we consider that there is some space between the vibrating body and the listener, there will be no sound being listened by the listener, यानी उसे कोई आवाज़ सुनाई नहीं देगी, right? Okay. The second point, the speed of sound in the air, ये value आपको याद होनी चाहिए. You must remember this, कि it is 330 meters per second to 350 meters per second according to different temperatures. It depends on the temperature as well, right? Okay. One more thing which you need to understand, that is the sound travels faster in solid than in liquid, and the least is the gas. That is, the speed of sound is maximum in solid, then in liquid, then in gas, right? Okay, now up till here things are going okay and fine. So one more concept, there are two more things which are being asked in the question, so I'm basically targeting the question and I'm trying to express that. So that is why I'm just targeting on a few concepts. One more thing which you should know is the wave equation, and wave equation is V is equals to F lambda, where V is the velocity of the wave, F is the frequency of the wave, and lambda is the wavelength. If you have any two of these things given, you can find out the third one, as is the case with every equation. The last but not the least is the concept of diffraction. So as you can see that the concept of diffraction is very well described over here. That is, for diffraction, let me write it down properly, just a second. Right, for diffraction you must consider two things. But you must consider the frequency of the wave which is being diffracted. It means if the wave have low frequency, it must have the long wavelength and the angle of diffraction will be more. If the frequency is high, the frequency high means there will be short wavelength and the wave diffracts with less angles. Let me describe it over here. For example, if I make two patterns of two different waves like this, this is one of the pattern which I am making. I'm just arbitrarily making a pattern so that you can understand. Just a second, let me do it over here. Now if you see that I'm making a wave pattern over here, I'm making two wave patterns. Number one is this one, right, and the second one is this one. So what is the difference? What is the difference between these two waves? As I already told you during the start of this video, that the distance between two consecutive crusts can be considered as the wavelength. So is there any difference between the wavelength of these two waves? Obviously it is visible that if you start from here and go up till here, you can see that this distance is more as compared to this. It has more wavelength. So if the wavelength is more, okay, you can also consider that the frequency is less. And if the wavelength is less, the frequency is more, obviously. Okay, you keep this fact in your mind. So what about diffraction? What diffraction has to do with that? You must remember that, for example, there is a sounding body and the sound is being generated. So you must consider that which sound has more frequency. So if the frequency is more, the wavelength is less. And for example, by the way, the sound is a longitudinal wave, but here I am, for the sake of just understanding, I am making it just like a transverse wave, so that you can have a basic concept. So if this is the sounding object over here, okay, and it is generating sound, right? Just give me a second. For example, this is a sounding object and it is producing sound. So if it is producing the sound of less wavelength and more frequency, so if the sound is going over here like this, okay, it will be diffracted with lesser angle, like that, right? Okay, but if the wavelength, if this same sounding body is generating the wave of, less frequency and more of the wavelength, for example, if I consider that this wave is going over here, so remember that the angle of diffraction will be more. That is, this wave will be diffracted more, right? Up till here things are going okay. So remember, if I explain it to you again in a certain different way, I can say that, for example, this is a body in between the sounding body and the listener. So if the wave which is being generated is of low frequency, that is, it has low frequency, it means that it must be longer wavelength. Longer wavelength. So if it is longer wavelength, it will be diffracted more at angle, yani it will be diffracted like that, more. But if the wave is less frequency, it has more frequency, and short wavelength, more frequency, and short wavelength, so it will be like this, it will be diffracted with less angle, like that. This angle is more, this angle is less. So this is what you have to consider while solving this question. I'm going to open up the question and begin to show you what is the basic idea which you need to keep in your mind while solving this one. Now look over here regarding this question. It says the speed of the speed of the sound is 340 meters per second. You have to calculate the range of wavelength for sound that are audible by the healthy human ear. So for the range of wavelength, you know that the wavelength, it's being given in the syllabus, that the frequency which is audible by the human ear is, starting range is 20 hertz to 20,000 hertz. But it's not being asked over here. It is asked that the wavelength needs to be given. For that you will use the formula V is equals to F lambda, right? Or if you have to find out the wavelength will be is equals to velocity upon frequency. So what is the velocity for the first case? It is 340 divided by the frequency, that is 20. If you divide it, you are going to get 17 as answer. Let me check it, just a second. 340 340 divided by 20. Yes, it's 17. So the wavelength is 17 meters. Wavelength, it's the lowest wavelength range, right? And what is the highest range? For that, what will you use? You will use the same velocity, that is 340, but the range which is, the highest range is 20,000 hertz. So divide by 20,000. So 340 divided by 20,000 hertz is going to give you 0.017 meters, right? So this is going to be your answer, right? Okay. Sound wave are longitudinal. This is the fact which you already know. Describe how the longitudinal wave are different from the transverse wave. So in that you can simply write कि longitudinal wave contains compressions and rarefaction, whereas the transverse wave carries the trough and the crest. Similarly, you can also say that a longitudinal wave, this wave is a special type in which the particles of the medium move along the direction of propagation of wave. That is, the direction of propagation of wave for the longitudinal wave is same as the particle motion is in the same direction as the direction of propagation of wave. But in the transverse wave, the direction of the wave is this. For example, from left to right, the particle will move up and down, that is perpendicular to the direction of propagation of wave, right? So these are the three differences. Now you can see that here comes the question. It asks you, shows a band in the front of the building. Now this is the corner over here. There is a guy who is a listener, okay, who is listening to this song. So there is a man who is playing the drum, and it produces the low frequency. Remember, low frequency means high wavelength, right? There will be more wavelength to it, right? And other musical instruments are producing high frequency. It means it has lower wavelength, like this. Okay? These sounds are equally loud, right? A young man at the side of the building hears the drum but not the frequency, because this person is actually, you can see the distance between this person and the corner wall besides which he is standing. So you can simply see that these are the other instruments. They are producing the sound which are of high frequency. So if the frequency is high, right, if the frequency is high, the wavelength is low, that will be like this. The wave will be low frequency, right? Low wavelength. So what will happen, when the wave will be diffracted from the corner, it will be diffracted less, right? So if I make this again, it will be like this. Right. So if I make the sound over here, the sound coming out from the trumpet, it will be like this, low wavelength. And when this sound will be diffracted from here, it will be diffracted with lesser angle, so it will move with lesser angle, and that angle will be more. So if I consider, to make you understand that fact, if I consider that this is the point from which the sound is coming, and this is the point for the listener, okay, so the sound coming from here will be like this, but this will be diffracted a little lesser, and the person is over here, okay, so he will not be able to hear the sound. Whereas the same type of setup will be shown over here, where the sounding body is here and here is the listener, right? But on this time, I will be considering the drum who is producing the sound with low frequency and higher wavelength. So the low frequency wavelength which will come over here from like that, okay, and it will be diffracted more, so he will be able to listen to that sound. This is what the fact is. So let me show it to you, the answers of that. You can simply see that our answers are actually matching, right? And simply go to the next part, that diffraction is mentioned. You have to mention the method of diffract, the point, that is this is here, over here the diffraction is happening. The wavelength of the sound from the term is low frequency and it has higher wavelength, okay. The diffraction is more in this, whereas in the other instrument diffraction is less. So this is what the reason is, right? Thank you very much for watching this video. Thank you.